Hello and welcome everybody. The topic for this video is applying the exponent laws. Before I begin, I just want to remind you that I made a review of the exponent laws video, so you want to make sure you check that out first before you attempt these. I'm assuming you know them and you're good at them, so now let's begin some examples. All right, so first thing you want to do is identify what's going on. I see here it's a multiplication. I remember from my exponent laws that when you multiply powers with like bases, I can add the exponents. So it becomes 1.2, and then I just simply add my exponents. So 1.2 to the power of 2. This example says to simplify. If it says simplify, you can leave it as a power. If it said evaluate, I would go further. So if it was evaluate, I'd write it as 1.44. But it's only simplify, meaning I can leave it like this. That is my final answer. Let's go to the second one. All right, more going on in this one. Okay, things I see. Well, I see power to a power. I also see its multiplication. So I'm going to deal with the power to a power first. Once I simplify those, then I'll multiply them together. So power to a power, I remember my exponent law for that. I multiply my exponents. So I'm going to get, here's my base, 5 to the power of 4. I end up just simply multiplying. Let me show you different numbers or color. I'm going to multiply those. So -2 times 3 is -6. Over here now, 5 to the power of 4. I multiply my exponents. 4 times 2, that is 8. So I've dealt with the power of a power, power to a power. Now I can see it's the multiplication left, so I just recall that exponent law, add the exponents. 5 over 4 to the power of -6 plus 8, that'll be 2 again. So 5 over 4 squared. Again, this is a simplify example, meaning I can leave it as a power. If it was evaluate, I'd square both numbers to get 25 over 16, but I don't need to. All right, before you begin the question again, take a second, see what's going on. I see there's a multiplication happening up top here. I also see I have a division going on as well. So I'm going to want to simplify the top first, and then I can divide. So I see that I have a multiplication, and then I'm going to have a division. Multiplying, that's adding my exponents. Division, that's subtracting. So again, if you know your rules, should be good to go. The big thing is just organize your steps. What are you going to do, and when are you going to do it? All right, so I have a multiplication. I end up just actually adding my exponents. So 0.7. and then now 4 plus 2 all over 0.7 to the power of -3. So 4 plus 2, I know that's going to be a 6. So I don't actually, 0.7 to the power of 6 divided by 0.7 to the power of -3. I've now done my multiplication. On to my division. Dividing, we subtract our exponents. So 0.76 minus, this happens to be a -3. So sometimes, or you always have to watch for sign changes. They're not always there, but I have a sign change, a negative and a negative. So that's a plus. So it's going to be 6 plus 3. So I get then 0.7 to the 9th power. Okay. Once again, I would go further if it was evaluate, but it's not. So that's a good thing. Simplify is kind of nice. Saves you a step. Okay, D, the final example in this set. All right, so if I check it out, it's actually a very similar question. I see that I have some multiplication on the bottom, and then it's a fraction here, so that means division, okay? Again, whenever you're dealing with, or I shouldn't say again, but whenever you're dealing with a fraction style question, make sure that you simplify the top and the bottom. Once you have one power on the top and one power on the bottom, then you can do the division. What makes this one a little bit more complicated is I see that I have exponent fractions. But we know how to add and subtract exponents, fractions, so it shouldn't be so bad. Okay, so the numerator it gets a break because there's no work to do. It's already 1 power. The bottom is where I have some work, the denominator. So I'm going to add those fractions, or those exponents, 1/2 plus 3/4. Okay, so remember that with fractions we need common denominators. So then this is going to have to turn into 2/4. So now it'll be 2/4 plus 3/4. So I get 6 to the power of 1/2 over 6 to the power of 5/4. Now that I have that done, that's my multiplication. Now I can perform the division. So for the division, I subtract my exponents. 6 to the power of 1/2 and then subtract 5/4. Again, you need common denominators to perform subtraction, so this is going to turn into 2/4. Continue over here. So now 2 minus 5 is -3, so 6 to the power of -3/4. And sometimes you're asked, simplify, but leave the exponents positive or something to that matter. And if that was the case, then I could go a bit further and I'd say, well, that's a negative exponent, meaning we got to move it to the bottom. So that is another way you could write that answer, but it just says simplify. It doesn't mention anything about leaving it your answer in positive exponents, so I can leave it like that. All right, another set of examples. I'm just trying to show you a variety of things. So here's just more variety. Okay, so when I'm looking at A over here, again, I want to look to see what there is to do. I notice there is a multiplication. And within the multiplication, I notice that I have different powers going on. Okay, so I'm going to have to watch for my like powers. So I'm not just going to multiply things randomly. I'm going to work with the like powers. When you do this, feel free to reorganize. So I could put my a's together. A to the power of 4 times a to the power of 3, and then c squared times c to the -4th power. So helps you see it. You don't have to perform that step. The next step now, actually do the multiplications. So I'm going to add those exponents. 4 and 3 will make 7. C, I'm going to go 2 plus and then -4. So once again, I have a sign change. So it really becomes 2 minus 4. So I get then a to the 7th power, c to the power of -2. If they ask me to rewrite this as a power with positive exponents, then I'd leave it as a to the 7th power all over c squared. So that's the little adjustment you'd make if they ask that. Example B. All right, so I see a division. It's the fraction. Whenever you have a fraction, we know that they're telling us to divide at some point. And again, I see like terms. So there's more than one type of term, and I see some repetition. So what I'm going to do is I'm going to actually look at the numbers, then I'm going to look at the x's, and then I'll look at the y's. All right? So 20 divided by 4, that's going to work out to be 5. Then I have my division here, so maybe I'll write in red for that one. No, I'll stick with blue. My division, so it's going to be 4 minus something, because x to the 4th divided by x. So what is the exponent that x has on the bottom? It is a 1. Everything has an exponent of 1. We just don't write those down because it would take a while to write a 1 every time you wrote a number. So then 4 minus 1, that'll end up being 3. So that's going to be x cubed. The y's, if you can do it in your head, great. And if you can't, 3 minus a -2. So 3 minus a -2. Sign change. 3 plus 2. So then I rewrite everything that I've already figured out. And then now that's going to be 5. All right, so hopefully these examples are making sense. Again, I'm just trying to show you some variety. Here's our last set of examples. You'll see some more fractions sprinkled in here. Again, if you know the basic exponent laws, all these questions are pretty good to do if you take your time and if you organize your steps. Okay, so as I look at this, this is classic power to a power, and I also see that power, it's a power or a product. I can't speak there. I see that I have a product. I have a bunch of different terms in there. But what's really shining through is it's a power to a power. Sorry, guys. Kind of lost my ability to speak there for a second. Okay, so power to a power, we know we multiply the exponents. And then now power of a product is what I was trying to say before. Power of a product. With power of a product, if you recall from the video we looked at or I made last time, that's when you end up just distributing your exponent to every power that's inside. Before I do that, I should remember that my 27 has an exponent as well. So this 1/3 is going to go to each of these exponents. Students often remember the back two, but they forget this 27 has the exponent as well, so it'll receive the 1/3. So that's something to watch for. Okay, so I'm just going to write that out. So 27 and then 1 times 1/3, x 9 times 1/3, and then y to the 6th power times 1/3. So reminder, when you're multiplying fractions, it's nice to go fraction to a fraction. So I'll just go back through and make fractions out of these whole numbers. It's easy to make the fractions, right? We just put it over 1. And then again, when we multiply fractions, we go straight across. So I'm going to get 27, and then that's going to be 1 times 1, 1 times 3, so 27 to the power of 1/3. X becomes x to the power of 9 over 3. Now, a lot of you likely reduce before you multiply, but not everyone does, so I'm going to stay away from that just in case. But just to note that reducing your fraction before you multiply is way better, but I'll stay away just in case some people don't know that technique. And then now y, I go 6 times 1, which is 6, and then 1 times 3, which is 3. Okay, so now I have these fractions and they're not in reduced form, so I should go back through and rewrite this stuff. So 27 to the power of 1/3. 9 divided by 3 is 3. 6 divided by 3 is 2. So it looks like I've done everything, but this looks kind of funny. And then hopefully you recall, well, that's a fraction exponent. So powers and radicals have a connection through fraction exponents, and that means I can actually rewrite 27 as the cube root of 27, and now my numerator in that fraction is a 1, meaning I raise the entire power to 1, the entire radical to 1, which won't do anything, but I can still write that. And then everything else, x cubed, y squared, it just gets carried along because I've completed all the work there. What's the cube root of 27? 3. 3 raised to the first power, 3 raised to the first power is still 3. So I get 3 x cubed, y squared. So there's a lot going on in that question, but again, hopefully, seeing we identified the steps beforehand, it didn't seem so bad. Okay, B. Again, I see a multiplication happening, and then I see that these, I would call these products again, because they're made by multiplying those different powers. Product, product. So I'm going to multiply, but I'm going to make sure I multiply the like powers. If you wish, like I said before, you can rewrite it. So I can go x to the power of 2/3 times x to the power of 4 over 3. I like rewriting it if it involves difficult numbers, like say these fraction exponents. I like writing it. So for the x's, I like writing it. For the y's here, I don't think we likely need it as much because those numbers are easier to deal with in your head, but it's not a bad thing to write out. So when we're multiplying, we have to remember that we add our exponents. So then it's going to be x to the power of 2/3 plus 4/3. And then the y, it's going to be 4 plus a -2. So the x's, the nice thing, we already have common denominators, so I can just actually add. So it's going to be 6 over 3. The y's, hopefully you're already ahead of this on me and you're looking, oh, that's going to be a sign change. So I'm going to have 4 minus 2, which is going to be then just 2. So y squared, sorry, I got the red pen still. I should simplify my 6 over 3, so that simplifies to 2, and the y I'll just carry along. And again, looked like a pretty intimidating question at the start here, because there's lots of stuff going on, but if you just take your time, pick out what needs to be done, it shouldn't be so bad. 2 more examples to help you. All right, C. I see the fraction, meaning I see division. All right. And we've done questions like this before, but now they have some exponents and some negative numbers, so it's just a tougher version of it. Once again, I want to make sure I work with the like terms. So I'm going to go with my coefficients there, my x's, then I'll deal with my y's. Okay, so 15 divided by 5, 3. X to the fourth divided by x to the power of negative 2. Well, I then just got to remember that it's division, so I subtract. So I'll have that set up. Y's division again, so I got to subtract 1/4 minus 3 over 4. All right, so the coefficient, the 3, it's already done. The x's, I have a bit of a sign change here. It's going to be 4 plus 2. So it's going to be x to the 6th. I hope you don't mind that I've gone with these colors now just to kind of color code things. The y's, there is no sign change, and the denominators already match up. So I just got to go 1 minus 3, which would be then y to the power of negative 2. And again, if the question asked you to say, or sorry, if the language of the question was simplify, leave all answers with positive exponents, I can then write it as 3 x to the 6th power all over y squared. This question does not have that language, so I am fine to leave it as that first answer. All right, we've come to the last example. Lots of stuff going on here. I see a division, I see power to a power, I see power of products, so there's lots of stuff. The biggest confusion for students is what to attack first. So what I'm going to suggest to you is we want to simplify, we want to tighten up everything that's in here first, okay? Then once it's all tightened up, we've done our division, then we can worry about bringing that exponent in. So if you look at this, there's not a lot we can really do that jumps out to me. I don't want to divide 49 and 64 because I'm going to get a decimal. So, but I see these a's here. I can work with those. So I'm going to rewrite what I have, and I guess I'll just deal with the a's. I'll do the a on the side here just so maybe it kind of, I don't want to complicate the work in my question. It's going to be a to the 2nd power divided by a to the 7th power, which then is a2 minus 7. So that's going to be a to the negative 5. So if I wrote that as a positive exponent, it'd be a5 on the bottom, meaning I want to write my a on the bottom of my fraction. So I'm going to get 49 only on top now because the a has moved. 64, a to the power of 5. And some people might be thinking, well, you could put the b up top. I see it's negative, and you can. You don't have to, but you can, and maybe I will. Just feels like it balances things out. Great. So I've simplified everything I could within the fraction, or sorry, within the power. Now I can bring this exponent from the outside in. So again, remember, it's the big thing that people forget. The numbers have an exponent too. They have 1s. So this 1/2 is going to go to the 49. It's going to go to the b. It's a fractional base, so the exponent goes to both the top and the bottom. It's then going to go to the 64 and to the a. So this 1/2 is going to go all over the place. And remember, when it's raising a power to a power, it means I'm going to multiply all these exponents. So hopefully I don't run out of room here. I get 49 to the power of 1/2. B, power of 1/3 times 1/2, because I'm going to multiply. 64, 1 times 1/2 is just 1/2. So if you're wondering why I just wrote 1/2 down, because 1 times 1/2 is simply 1/2. A, this is going to be 5 over 1, I'm going to write it as, because I know I'm multiplying by a fraction, and that fraction being 1/2. Okay, so 49 to the power of 1/2. Remember that 49 to the power of 1/2 really means, I'll write it over here, 49 to the power of 1/2. That really means square root of 49. So that's going to equal 7. B, I'm going to multiply that. So top to top, bottom to bottom, 1 times 1 is 1, 3 times 2 is 6. So it's going to be, oh, well, I'll leave it as that. 7b to the power of 1/6. Sorry, to the power of 1/6. The bottom, 64 to the power of 1/2. Well, that ends up being the square root of 64, so that is 8. The a, again, I multiply straight across. It's going to be then 5 times 1, which is 5. 1 times 2, which is 2. So 5 over, oh, sorry, a, 5 over 2. And then that's my final answer. So again, it looked like a lot, but I just took my time. I simplified my what was in the brackets first. Once I simplified, then I worried about the power to a power. And then after that, it was really, I just had to do all my different multiplications and all that the power to a power required me to do. So that's everything I got for you. Hopefully you checked out the review first. Now you've seen a bunch of examples. Exponent laws can be difficult, but just take your time, everyone. If it doesn't make sense, find your teacher, come talk to me. Have a great night.